The website wherein you can see all the sklearn related modules and methods and packages related syntax here. Okay, you have something called Cohen Kappa score, y1, y2. This is the formula for this, and P. This is the Kappa statistic formula. K is equal to P0 minus PE is the probability of agreement on the label, and P is the expected agreement when both annotators and randoms, and this is the formula for this. Okay, and here you need to pass y1, y2. Let me just check any example for this. Yeah, here the Stack Overflow is also very good community. Y1, y is the predicted value and actual value. Simply if you pass this one, you will get the Cohen-Kappa score. So now the question is, you have something else, because simply if you, you don't have to remember everything. And if you look at here, the Kappa statistic, if you get the value, something like 0, then no agreement. If you get anything 0.6 and above, then there is an agreement. Okay. So P0, the related observed experiment, observed agreement among raters, and the hypothetical probability of chance agreement. Okay. And this is the one, hypothetical probability of chance agreement. So is it due to chance, or what is the chance that is it due to chance or not? To check that, we are going to use Kappa statistic, but don't ask me much about this. Okay, you don't have to be aware of that much detail. Now what I do is simply you go and check with the reference value. That is enough. If the Kappa statistic value is 0.6 and above, then you have, your model is kind of good. Okay, we are getting this value 0.09, 0.09, right? So somewhat slight agreement. Okay, it's not so good, right? Had we got something like a point 0.09, oh, then 0.09 is not good, right? So it's not even 0.1, no agreement. According to the Kappa, it is not good. Okay, this is another thing you need to remember it. Okay, but simply right, you use this one Kappa score and check if this is this value is or within this referral range, and if you find something closer to 0, then there is no agreement. But again, this is not the only metric we can make a decision. Okay, so we literally go by the accuracy score. As I told you yesterday, accuracy score is also not much helpful. Look here. Here, which one is the true positive? My model was able to predict, my predicted churners are 5, but actual churners are 5 here, right? But here the 79, right? 79 customers were wrongly predicted as non-churners. Okay, my model was able to predict only the 5 customers as a churner. Ideally, it should be 84, right? It's not good. So what you do is, in this case, probably you can play around with this label, sorry, the threshold value, and also the RFE. You create the reduced model and see how it works. And again, even for the reduced model, you need to use the threshold. You can change it from 0.6 to 0.7 or 0.8. You just play around and then you check this one, right? You check the confusion matrix and check the, importantly, this is the important thing, okay? The confusion matrix and the accuracy score, right? And then you need to AUC. These are the important thing you need to set. And along with that, you need to see the precision and classification report, precision and recall. Look here, the precision, recall, and FN score. Okay, this one, if you see here, the accuracy is 0.87, but if you see here, the precision, right? The precision is high, but whereas the recall is less. That means the false positive is less. The higher the precision, the false positive is less here. So this is the false positive, right? So we can see that, less here, whereas the false negative is high if the recall is very less value. If the recall is less, that means your false negative is high. Okay, you need to improve on this one. Again, depends on your use case. If you wanted to reduce, what is the goal of this exercise? You want to capture more number of churners, but it shows only your model was able to classify only 5 customer churners, right? When you use the test data set. Similarly, you can check for the training data set also. Okay, here you need to pass training label train, and this is even for that, right? You need to use, or you can directly use that predict function for the training data set. Okay, and you check it out. So what value are getting, but it is not good. Though my model was able to predict only the 5 customers as the churners, right? My accuracy shows 87. So do you think we can rely on accuracy? If you go and tell your manager, my accuracy is, so if I round it off, 90, if you go and tell him accuracy is good, and if you share him, if you tell him my model was able to correctly predict 5 churners, whereas 79 customers it wrongly predicted as non-churners. Do you think you will agree with this one? So in that case, we cannot rely on this one, right? So you need to, in this case, you need to reduce this value. So how do you reduce this value? That is the next exercise. How we are going to reduce the false negative value? You play around with your threshold value. You reduce your threshold value. Okay, and then you see what is happening. Okay, instead of 6.60, you make it 0.4, right? You try with that and increase it. And increase it. When you increase the threshold value, you will get more true positive. Whereas when you reduce it, you will get, when you reduce the threshold value, your false negative can go down. Try with that. I just gave you the clue. Try with that. So actually, I thought of covering the decision tree today. Let it be there. Decision tree concepts. If you understand this one, the same thing is applicable for decision tree. All the things, and also in my strict, script. If you see here, I have initialized the random forest classifier, and also I have used all the things, the same steps, gradient boosting, everything. Okay, and for all these things, look here, I just finally compared all these 3 models. In this case, I have used 3 different algorithms: logistic regression, random forest, gradient. Of these 3, random forest, logistic regression, yeah, this is the diagonal line. So your curve should be far off from this diagonal line. Okay, so here this one logistic regression is somewhat closer. My logistic regression is not doing good job. Look here, random forest is really doing good job. But compared to random forest, gradient boosted tree is doing far better job. Sometimes even with the reduced model, if you cannot see any improvement, then you can use different algorithm, random forest, gradient boosted tree, and then you compare all these things. So this is the script. You don't worry about these scripts, okay? And you focus on the core area, okay? And what is the idea? So now with gradient booster, we can see that. So what I would here, I did not I did not define the threshold value. Without defining threshold, I checked it. Now what you do is with the threshold value, you just change it, or with the same threshold value, you can fit this one. Okay, you can create this chart, and then see which model AUC is more. So if you see here, this curve, under this curve, the area under the curve is less compared to this curve. This curve, the area under this yellow curve is more, but the area under the green curve is very high, right, compared to all the other two. Okay, hence gradient boosted tree is doing good job. Okay, and only thing is, look here, finally you need to compare all the confusion matrix. With this itself you should be able to understand. So logistic regression 559 non-churners, here it was not able to detect even a single customer, right, as this thing. And this one was without defining the threshold also. Okay, and because this is a working copy of my script, I changed the threshold with different value and I just tried it, and I compared the confusion matrix for these three different models, and here you can see the 32 is true point. It's good, right? So 32. The 84, the false negative got reduced. When you see gradient boost, the false negative got reduced further. From 84 to 37, it got reduced. Okay, so in this case, the objective is we need to reduce the false negative. Okay. Okay, I'm done. What we will do is next, the scripts are there for other algorithms, other two algorithms. But in the case of decision tree, the so the topmost algorithms are like cat boost and gradient boost tree. That's what I have the script here, but xg boost is there, and then we have something else called ada boost, and other thing is light gbm. Light gbm is the best one because with that you can see good accuracy. Okay, and XG Boost was very good in those days, but of late, they recently they came up with this one, the LGBM. Okay, and light gradient boosted tree. With that, you can see good accuracy. Okay, so if you fit that also, and if the curve goes above all this thing, that means that that algorithm is better than all the other thing. Okay, so here, what you need to note down here is for the decision tree, right? I have used pip install, XGBoost. Or else you need to use this one. 1 second, confusion matrix. Okay, here I did not use XGBoost. This is my gradient booster tree. The next one is XGBoost, same step. Use the initialize the model, fit the model, and then apply the model on the unseen data by making a prediction. That's all. Okay. Compare all the models, whichever model. But in the case of XGBoost, you need to install it. So for that, you need to use something called pip install. Pip install XGBoost. That's all. And then click on the run. It'll get. Since in my system I already installed it, you need to install XGBoost also. And anyhow, we will discuss about the decision tree next weekend. We will wrap up the decision tree next weekend, and then we will continue with the unsupervised machine learning algorithm. Okay, most likely next weekend, once I complete the decision tree, the rest of them will not take much time. Fine. You have any questions? I think this timing will work out for all, right? Okay. Fine. Since you don't have any questions, I'm going to wrap up the session. We'll upload the script in my website. I thought of uploading yesterday because of that thing, right? I did not upload it. And again, I include a lot of changes here because this is the step that you need to follow it. Okay, and this is the workflow. First, you need to clean the data, data wrangling, all the things, and then exploratory analysis, As part of exploratory, univariate, bivariate, all the things, and then you need to gain insight. And next you see any collinearity, drop those variables, and then RFU, all the things, right? This is the proper flow. And that's why I did not publish any of this. Has got everything in it. So this is pretty much simple when it comes to coding part. Look here, you learned everything in one thing, right? So gradient booster tree. Only thing is XGBoost. I did not update it here. I should have updated. Anyway, I'll update it here. Okay. XGBoost, everything, all the models, all the algorithms related to supervised machine learning. If you try it, right, for this one, except linear regression, you cannot use linear regression for classification. The rest of the classification related algorithms like light GBM, all things, if you use it and if you compare it, each model's accuracy, all the things, precision, everything, right, you will be able to understand which model is doing good. But any of we have something else called imbalanced data set. Advanced topics, right? We will discuss it after completing all these algorithm which I promised to complete, right? That we will discuss. Imbalanced data set is there, how to deal with imbalanced data set. That and all we'll discuss it after completion of this training program. Okay, after completion of the machine learning, everything. Okay, fine. Thanks, guys. Thanks for all your patience. I took 16 more minutes than what I scheduled. See you next week.